So, welcome to this course on principles of digital communication on behalf of the entire NPTEL team. I am Abhishek Dikshit and I am a faculty in the Department of Electrical Engineering, IIT Delhi. Well, as the name of the course, Principles of Digital Communication suggests, in this course we will learn the key principles that are involved in the designing of a digital communication systems or all communication systems, because all communication systems around you today are digital communication systems. So, if we look at the examples of a digital communication systems, examples of a digital communication systems are mobile communication systems, a telephone system, a TV system, and internet. All these are examples of a digital communication system, and in this course what we will do, we will learn what are the key principles involved in the designing of these communication systems, right. So, let us ponder a bit what are the objectives of this course, what key skill sets that you would possess after you have finished this course. So, to explain this, let me take an example of a digital communication system. Let me take example of a mobile communication system. So, an end-to-end mobile communication system is very complicated, and if you have to assess the design changes of a mobile communication system, you have to run through a computer simulation. But in this course what we will do is we will break down this end-to-end digital communication system into smaller blocks and smaller pieces, and we will solve problems for each block and each piece, and doing this what we would develop is an intuition to understand what works in a block, what designing principle will work for a block and what principles will not work for a block, and also we will understand clearly the interactions among different blocks. And this is what the objective of this course is. We like to develop intuitions to understand what might work and what might not work in the designing of a digital communication system. I will also like to warn you that the scope of a digital communication system is quite wide, and in this 12-week course we will not be able to cover all aspects of a digital communication system. Basically what we will do is we will focus on these three blocks of a digital communication system. So, a typical digital communication system consists of a transmitter, a channel, and a receiver. So, if we are looking from the perspective of a mobile communication system, the transmitter is a mobile tower, the channel is the air medium, and the receiver is the mobile unit. So, transmitter produces the information signal travels through the channel and then it is received at the receiver. So, these are the three blocks where we would concentrate most of our energy. Typically what goes in these blocks also I would like to point out that to you. So, typically in a transmitter what we would do is we will assume that we have a binary sequence available. That means a binary sequence is a sequence of ones and zeros, and then we will worry about how to convert this binary sequence in a good waveform. A waveform is just a function of time or is a signal of time, right. So, you need to convert this binary sequence into a waveform so that it can travel over a channel, right, and we will understand what are the good ways to do that. Then the channel will corrupt this transmitted waveform, it will add noise to the waveform, then at the receiver we would have noisy waveform, and then we will worry about how to convert this noisy waveform into a binary sequence, right, at the receiver. So, typically this conversion of a binary sequence into waveform is known as a modulation, and the conversion of a waveform to a binary sequence is known as a demodulation, and in this course we will basically focus on these three issues. We will understand modulation, how to do modulation, we would understand demodulation, and we would understand channel and channel noise. So, this is where we will keep focus on this course. Now, I will like to present a week wise overview of the syllabus, the topics that we would cover in this course. So, first as you would guess, we would start with the introduction to digital communication. We will talk about the signal spaces, then we will see how to geometrically represent these signals, then we will provide a review of random variables and random processes, and then we will go to waveform coding. So, waveform coding basically deals with the fact that if you have an analog waveform, how can you generate a digital representation of that analog waveform. So, that means how can you get a sequence of ones and zeros for this analog waveform. Then after obtaining the sequence of ones and zeros, we will try to think how to find the good analog waveforms for this binary sequence, and this is, as we have said, is known as a modulation. Then we go into the domain of hypothesis testing, which is same as demodulation. That means given a noisy waveform, how can you generate a binary sequence for that noisy waveform in an optimal way. And finally, we would do the performance analysis of several modulation and demodulation techniques. The prerequisites of this course is very important. So, you should have thorough knowledge of signals and systems. At least you must be aware with linear time invariant systems, you must know convolution, you must know Fourier transforms. So, if you do not have a background in signals and systems, I would not advise you to take this course. Then secondly, you should have basic knowledge of maths, you should know probability theory. So, this brings us to the end of this introductory video. Wish you all the best, and I hope that we will have fun together learning this course. Thank you.